Hey everyone, Mr. Taylor here, trying to talk about some one-step equation by multiplication or division. Well, as we know, when we're solving equations involving multiplication and division, we perform the inverse operation. Now, as we said earlier, these are going to look like fractions to us, but hey, we can just jump right in and do what we need to do. First one, solve x divided by 5 is equal to 4. Well, we'll look at the side that contains the variable, and as we can see with that particular side that x is being divided by 5. So what we want to do is multiply both sides by 5. Once we do so, we will have, because the 5 is going to cancel out, x is equal to 20, and that's be 4 times 5 is going to give us 20. We will go up and check by going back to our original equation, which is x divided by 5 is equal to 4. And what we will do is replace x with 20, and we'll ask ourselves with this question mark, does 20 over 5 equals to 4? And when we simplify, we see that 4 indeed equals to 4. We'll put a little check mark there and say we have an identity because the left side equals the right side. Next question, negative 3x is equal to 27. So here we're looking at x is being multiplied by negative 3. So the inverse operation will be to divide both sides by negative 3, which is what the author has done here. And a negative 3 and a negative 3 cancels out to 1x, so there's our x. And 3 goes into 27 9 times, but our integer rule says when we divide a number that is negative or positive by the opposite sign, in this case a negative into a positive, we get a negative for the answer. So when we simplify, we will get x equal to negative 9. Go back and check it, and when we check, go back to the original formula, which was given, a negative 3x is equal to 27, so we replace x with a negative 9. 3 times 9 is 27, and a negative times a negative is a positive. So we indeed get another identity because 27 does equal to 27. Okay. Let's see, can we finish this up by looking at this little scenario that we have. And what they're asking us to do is determine, ooh, that is so not straight. Okay. Okay, now we got that straight. They're asking us to determine if, what are the correct words for each sentence and then solve the equation. So we see x and we're wondering what is going on with x. So we come here and look at what they're saying. Is it being multiplied or divided by 2? Well, it's in the denominator, so apparently it is divided by negative 2. So to solve, since it's division, the reciprocal or the inverse operation, I'm sorry, please throw away that word reciprocal. The inverse operation would be to multiply both sides by negative 2, and when we solve it, we will get a negative 14. Going to problem number 2, it says, is m multiplied or divided by 5? Well, it's serving as a coefficient, so it is being multiplied. And to solve, the inverse operation says we divide both sides by 5, and that's going to give us a negative 8. Okay, so now we're looking at the second problem. It says to solve each equation and check. I'll let you do the checking. We have a negative 2x is equal to 20. Again, it looks like problem number 2 above. So that means that we must have to do division. So we'll divide both sides by negative 2. And if we do, we will get an answer of 10. Okay. Going to the next one, we see W, looks like problem 1. W is divided by 5, so we would multiply both sides by 5, and we will get W is equal to a negative 35. Okay. Looking at problem 6, it says 6z is a negative 42. Again, that coefficient is right next to that variable, so apparently we must, that means we're multiplying and we must divide. So if we divide both sides by 6 there, that's going to just give us that little z, and 6 goes into 42 7 times, but it's going to be a negative 7 because 6 is positive and 42 is negative. So that's pretty much what we're looking for when we are looking at these particular problem set. So it's not going back to the very original. So it's not anything that's too nerve-wracking. Just pretty much follow the rules, and you should be able to determine. And that is going to be no, actually not. This is wonderful. So we have a continuation here. And since we have a continuation, let's let you take a minute, if you don't mind. Stop the video. Take a look at what we have. And once you take a look at this, make sure I get it good and nice and straight for you. There you go. Take a look. Read the actual practice problem that they're giving you and the check. So once you read that, these are these fractions though. Oh man, I love it. Remember that reciprocal. Remember what it means by the reciprocal, but I want you to take your time and read this, and once you read that, if you don't mind, bring in problems 6, 7, 8, 9, and 10 for a little bonus work. So again, and then see, you can just take, you can go back and forth to that. Oh, did I do that right? Is that like problem? Okay. So do that for me, please. Stop the video and look at these real good, see what the examples are, and then come back and work problems 6, 7, 8, 9, and 10. And thank you so much for being a part of Rockin' Math. I'll see you soon.